So if we take your example, what you were describing was a part of the process that requires the payroll to know how many hours are worked for people who work variable number of hours. So again, whether you do it manually or whether you do it automatically and integratedly from other systems, depends on the approach you're using, but it's still the intrinsic part is it needs to know the number of hours. So again, when we begin to look at processes, we begin to find that if we break them down, that there are universal sets of ways of doing it. So now, one of the powers from a management perspective is you can question, are we using the most effective and efficient procedures? So I may have a manual, but I could look at the cost effectiveness of changing to an automatic computer generated hours. So that's, but the point is, intrinsically, it has to be done.
So the second implication, Jim, is that we have these processes and we can measure the performance. And the key here is that the better the performance, we're trying to get some ideal outcome. Can you expand upon that?
Yes, and let's return again to your example. So if one of our goals is to be able to put in, to be able to pay people, and we need to know what hours they worked, then part of the trade-off you would have is, among other things, how many employees you have. So if I have 2 employees, I'm probably not going to buy a sophisticated computer system that's going to automatically do all the updating. I'm probably, when you look at the cost effectiveness, going to use a manual system. So once we begin to understand intrinsic processes, we can then begin to understand the cost effectiveness, and at what point do we now want to move from a manual to a computerized system, for example. All that's very quantitative. And if we had a good understanding of our processes, then we should be able to be in a much better position to make those trade-offs.
The third implication is that processes have intrinsic performance measures. So I would imagine if we stick with our payroll example, is no matter what system you use, you want to pay employees accurately. I would assume you would want to pay them on time, okay? And those are intrinsic to the process, and regardless of whether you do it manually, whether you do it through computer applications, the performance measures are the same: accurate payment, pay them on time.
Absolutely. And that's where we get into the idea of outcomes. Because outcomes means every process has a purpose and an intended outcome. And by understanding those intended outcomes, then we can determine whether or not we achieve that outcome through our performance measures.
So the fourth implication is that processes are relatively stable. So if we have a system to pay employees and they fill out a time card and that's what they do it over and over again, we can more or less expect the same results week after week, month after month, subject to natural forces and environmental factors. Likewise, if we suddenly automate the system, we can more or less within a certain range expect a consistent outcome unless we change the process in some ways.
Absolutely. And the other aspect to it, in addition to what you so well articulated, was that in most cases, process knowledge is evolutionary. So again, if we were to go back in the history of payroll, you're probably going to find today's payroll systems are fairly similar to the way they were for many years. And so what you then see is most organizations are going to have many processes that are fairly stable, that are not changing on a daily basis. And so by doing that, they should focus on getting those processes efficient and effectively, keeping those there, and then turn their attention to the other processes that are much more dynamic. So it enables an organization to constantly keep their eye on all their processes, which are critical, but also then to devote most of their attention to the ones that they need to, they can gain a competitive advantage or are very dynamic.
The fifth implication is that there's only a finite number of ways to perform a process. And like you said, sticking with the payroll example, you can either do it manually, you can do it with a computer system, you know, but you're not going to grow flowers, you know, to
Right.
pay employees. You're not going to jump out of helicopters to pay employees. And within that certain range, there's a finite number of ways to perform a process. And therefore, that makes it very practical. The sixth implication is that process improvement is empirical. And can you talk a little bit about what makes it empirical and why is that important as we look at process management?
Sure. First of all, let's start off with what we mean by. Can we stop for a second?
So I'll start
Sure.
or yeah, just
Ready. What we mean by empirical is that an organization who uses intrinsic processes, and again, the vast majority of our processes, in fact, almost all processes are intrinsic, that we should be constantly looking for the appropriate point in time in which to change our process. And again, because processes are intrinsic, we can quantify what the factors are that are that bring us to that point of which we should change processes. So if we were to look at in manufacturing, a new robotics system, then we would know the cost of the new robotics. We would also know how many parts need that process to be performed. So when the volume of parts that could go through the robotic process reaches a certain point, then at that time it becomes cost effective to be able to change and upgrade the technology. So by looking at technology, we should be able to put within our management systems almost an automatic trigger that does analysis, that goes and looks at the key factors and then says, oh, now we ought to look at this process and perhaps this is the time we ought to make a change. So the idea is that with intrinsic processes, we can do some automatic scanning of our processes, looking for certain sets of conditions to occur. And when they occur, then that should highlight to management that you ought to look at a change in the process.
So if we move on to corollary 1b, it says all processes have physical limitations. So when I read that, Jim, I think of someone taking a sledgehammer and cracking big boulders, but if I took that same sledgehammer and tried to slice lunch meat, I probably wouldn't be very good. On the other hand, if I took that lunch meat piece of equipment and tried to break big boulders, that probably wouldn't work either very well either.
But one place where this was used quite extensively and it helped shape my thinking was at Levi Strauss. There we looked at the sewing operations of how you produce a jean. And what we found as we went from one operation to another was a common set of problems. So whenever they had a standard blue jean that they were sewing, their efficiency was the highest. When they had to make a purple jean or a white jean, their efficiency dropped considerably. And the reason was the technology, because every different type of color, the shedding of the material was different, and the one that operated the best was blue. Also, factors such as oil on a machine, the sewing machine, if it was white, it showed up. If it was blue, it just blended in, and it didn't get rejected for quality problems. So, again, what that means is every process has what I call a sweet spot. And that sweet spot says if we do A, B, C, D, then under those conditions, we're going to be at the ideal use of our process. But the reality is we're often asked to do something else beyond the capabilities, the sweet spot of the process. When you get that, then the quality and cost go up dramatically when you're not in your sweet spot. And so at that point, you make a determination, that's fine.